Welcome back, friends. We have been building the Caesar cipher. Though I'm not sure if you have realized that there is a deficiency in the implementation that we have done so far. In fact, our Caesar cipher right now will work only with lowercase or say small letters. In this video, we'll see how we can fix this. We'll see how we can make our Caesar cipher work with say capital letters or even with numbers. Let's go back to our code and see why what I'm saying is correct. Why is it that I'm saying that our Caesar cipher will fail when I give a capital letter? Remember, I'm here, got a simple implementation. Let's say I ran this code X is ABC and everything is fine. If I said X, E, and C, my shift here is 1. If I look at X, E, and C, I get a BCD. However, let's say I said, let me try to do A, B, C. Now remember, big A is not same as a small a. And here I have done X is equal to big A, B, C. Now, when I run this code, this time round, what happens is that if I look at X, E, and C, it has in fact become A, C, D. So it looks like B and C kind of shifted nicely, but big A only became a small a. And the question now is, why did this happen and how can I fix this? Well, first let's try to understand why did it happen. Remember, our function here is looking at every letter by letter, and that's happening through indexing through this variable I. And what I do is that I say, okay, let me find out where this letter is in the alphabet. So I go and find out the index of this letter inside this list, inside the string called letters. But what happens if I do not find that character inside the string? So let's just see this for ourselves. Let's say I said letters dot find A. I get a 0 because indeed that's correct. Letter dot find B is 1, which is indeed correct because A is the first letter of the alphabet, B is the second letter, and those are the indices in the list letters. But if I did, let's say A as a big letter, letters dot find a big A, I am going to get a -1 because mind you, big A is not same as a small a. So when we try to find big A inside this list, inside the string, sorry, letters, I could not find it, and hence find method returned me a -1. And notice that's exactly what happened here. I got index of -1. The first letter was a capital letter. I got index of -1, and hence my new index became 0, which is why X, E, and C, which took letters of new index, it took letter 0, and hence I got an A. Now, if you think carefully through this, you will realize that I can put any alphabet here. I can put, say, M, B, C, or let's say I put, say, K, B, C, right? Just for illustration's sake, I'm still going to end up with X, E, and C of A, C, D. Why? Because no matter what big alphabet I put in, my find method is going to return me a -1. Similarly, let's say I put in a number here, right? Let's say I put a number 1, let's say BC. I'm going to get again X, E, and C will be will be the same because remember here index has become -1. So in short, our function is not working for capital letters and for numbers, right? Let's see how we can fix this. In fact, we can fix this using a bunch of string methods. First thing first, just like we have a string called letters, we can in fact create a uppercase letters by using the upper method. So I can just say, for example, letters U is equal to letters dot upper. Now what this will do, so if I just ran this code, I'm going to, so let's just look at letters. Letters is indeed all the small letters, but letters underscore U is all the large letters, right? All the big letters. What I'm getting at is that I am not going to just search in the string letters. In fact, I'm also going to search in the string uppercase letters. How do I know which string should I be looking at? Well, I can make use of another method called the lower method. It's actually called islower. So for example, if I say X, so X is right now ABC. If I say X0 dot is lower, I get a value true. Now this is a boolean value, this is not a string. So this is a boolean value, it's saying it's true. So what I can do over here is that, remember this part is just a space. This is where I handle every letter. I can put a condition that if let's say Xi dot lower which means that this is true, then sorry, it should be is lower. My bad here. So is lower. Then I can say find index inside, let's say, letters, and everything is going to just follow from here. So I'm going to say tab, two tabs here. I must indent this now because there's an extra if that has come in. Let's just keep this print statement also. In fact, this is part of the statement itself. And indeed, I'm going to form X from here. However, let's say I can put an elif condition here, and I can say elif x dot I, x square bracket I, say is, I think there's an is upper as well. So I can say is upper, which means that I must look now, I must do all of this, but I will do it from the list, from the string letters U, right? So I'm going to find this in, say, letters U, and I'm going to, everything is going to behave exactly the same, just that the last version also has to become letters U. Now you might wonder, why did I not convert this X itself to say upper or lower using the to lower method and so on and so forth, and to convert to lower or upper? The reason is that I want I basically want to make sure that a capital letter is returned as a capital, small letter is returned as small. I could have converted the case, but then I have to keep track of where I have converted the case. So I thought this is an easier method. Now let's see what's going to happen. If I run this, for example, so let me see if I'm giving, so I'm giving ABC. Let me just make it say KBC. Now if I run this code, what happens is that I get index is 10, and I mean index is 10, but this time round, for the first one, it has actually looked at, uh, uh, you know, uh, looked at, let's say, this part of the loop. And if I look at X, E, and C, I'm, oh, sorry, I got this wrong. So it should be X, E, and C. In fact, it has become LCD because I, J, K, L, and indeed it has, shifted this by one letter, right? Now, you may want to extend this function further, and you may say, okay, I don't want to do this in letters. I also want to do it for numbers. So I can create a string called, say, numbers. And this numbers could be, for instance, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Now, if you want to go higher than this, you can, but then it may be better to use lists over there. But let's say we just want to stick with these numbers, and we want to be able to shift these, but we have to be a little bit careful because now it's no longer going to be a shift of, say this thing modulo 26. So what will happen is that now I can use another function which is numeric, right? So I can go and put in here, say elif, say xi, and I can use this function called is numeric. So remember, is numeric will tell me, return me a true if this is a number, right? And this returns a boolean as it says here. So if it's numeric, then I'm going to do the same thing again, and I will, this time round, instead of letters, I'm going to find this from the list from the string numbers, and the new index I will do index plus n, but I will make it modulo 10 because really that string has got length of only 10. There are only 0 to 9 until 10 letters. And after this, again, I'm going to just, it's going to follow the same thing here. Let's put numbers over here. Now, just to make it more clear, I can just put, say, one more print statement here. Let's call it, let's say, small I, we'll make it a little bit bigger here. And then we'll say, let's say, big I, and then we'll say, for example, number I. So we know which loop it really went into. Now over here, I can give, let's say I give a, statement of, say, KBC1. Now if I run this code, what happens is that I first went into the big I, it was 0, index was 10. I1 and I2, I went to the small and small because these two are small. And then finally I went to the numerical side, which was number. And what did I get as the, it was 1, so I was 3, index became 1, new index is 2. So if I look at that X, E, and C, I'm getting LCD 2 because K became L, 1 became 2. Now, in case you're wondering how are you to remember all these, different methods, well, worry not. As I've told you before, these string methods are available to you in this website. In fact, I mentioned this to you. look at these. There's no point in trying to memorize this. Try to find opportunities to use them, as I always tell you. And this I thought was a really good opportunity for us to practice, right? Now, in fact, we have a quite a robust function. We can say, maybe if I have, say, KBC 1211, and let's say I shift it by, say 10. So let's see what's going to happen here, right? If I give it a shift of 10, of course, the numbers, I don't expect the numbers to change, because shift of 10 will become same as 0, because there are only 10 numbers. So if I look at x, say x, enc, indeed I'll have ulm 1211. So maybe shift of, say, 5 is more interesting, because so the numbers also change. And if I did that, then if I look at x enc, you get something here, right? Now, this, I hope this made it clear. Remember, the basics are all in place. Basics are already in place. We're just using those basics to create a bigger and bigger function here, right? And really, that's about it, right? So I hope this made it clear. Take care. Thank you so much. Bye bye.